This is Maxwell Jung, and here's my demo of a CPM project for ECE 194BB. So my technical commands are here. So first I initialize the block RAM so that address 0 is filled with zeros, address 1 is filled with 1s, address 2 is filled with 2s, etc. until address 7 is filled with 7. And then I initialize the offset to hex 0xFF, or pure 1s. And then I assign the multiplier to 2. And then this command reads address 0, this command reads address 1. This command complements the data in address 2 and address 3. These two commands add offset to data in address 4 and 5. These two commands multiply the data in address 6 and 7 by 2. I'm going to copy those commands, run the trigger, and execute. And I'm capturing when the command goes to 10, which stands for addition, and the address is 101 at 5. So I should expect the CPM to add offset of 0xFF to the data at address 5, which is 5555. And if you run the calculation, that should be 55555654. And you can observe that in the waveform here. So here the command transitions to add offset to address 5, and then here the CPM finite state machine turns the enable signal on the BRAM port B, and also it sets the address to 5 times 4, or 20, and 20 in hexes 1-4. And then on this clock cycle, the offset of 11111, or in hex 0xFF, gets added to the data from the memory, which is 5555, and then that gets stored to the results GPIO, which is 55555654. Here you can see the results of my technical commands. So the first block writes to the BRAM. The second block writes the offset and the multiply GPIO. This command reads address and data 0, which is 0. And then this command reads address, data and address 1, which is 1. The next command reads the data and address 2, and it complements it. So the complement of 22222 would be DDDDD. And then the complement of 33333 would be CCCCC. And the next two commands adds to the data in address 4. So 44444 plus FF would be 44444543. And the next one adds FF to address data in address 5, which is 555555. And then the result of that is 55555654. Next command multiplies 666666 by 2, which is C. And then the next command multiplies 7777 by 2, which is E. And here's my timing report. And here you can see that I don't have negative slack.